Greetings everyone, this is my main project called as easy Abnormality identifier. So basically there are three different stages in this project. Stage 1 is known as initialization of the database. And the second stage is also called as the giving input stage. And the third and the final stage is comparing the both inputs and the outputs. Comparing inputs with the database. As you see, I'm going to explain the three different stages in this program. The first stage is about making initialization of the database. In this stage, we take four different ECGs. One is normal ECG, the other one is dystocardia, another one is hyperkalemia, and another one is myocardial infarction. As we take these four different ECGs, we compare it with respect to wavelets using the code known as WaveDeck and WRCOF. WaveDeck does the one-dimensional decomposition of the ECG, whereas the WRCOF makes the one-dimensional reconstruction of the decomposed ECG. After calculating the WRCOF of the WaveDeck, we will then plot the resultant output, which is, for example, consider D2 with respect to wavelets. We then plot the following output of the ECG. With these steps, we initialize the database. For normal ECG, which is D; for dystocardia, which is D1; for hyperkalemia, which is D2; and for myocardial infarction, which is D3. And with this, we are done with the stage 3. Now coming to stage 2, which is known as giving inputs. In this stage, we give the input to the system or consider. For example, consider in these circumstances as normal ECG. We then convert the normal ECG to its respective wavelets using the codes WaveDeck and WRCOF. Consider the wavelet of the normal input with I. And with this, we are done with the stage 2. And the final and most critical stage of the project is comparing the inputs with the database. Once we compare inputs with the database using the formula is equal. Consider in this instance D, I. For example, D is a normal ECG wavelet and I, as we know, is a normal ECG wavelet. Once we compare D, I using the code is equal. The output of the TS becomes 1 when both the wavelets are equal, and else it becomes 0 when both the wavelets are not equal. As we know, both the wavelets of D, I are equal, we get the output as 1. If TF is equal to 1, we pop up a message box and it shows that the wave is normal ECG, and again we pretend. And if it's not a normal ECG, we get this resulting as the input is not an abnormal ECG. And we do the same process for each and every wavelet. When comparing the normal ECG wavelet to dystocardia, since both are not equal, we get the output saying as the input wave is not dystocardia since it has no P wave. The basic difference between normal ECG wave and the dystocardia is that dystocardia has a presence of negative P wave, which is completely different from the normal ECG, which has a positive P wave. Since the wavelets of is different, we show the since the wavelets are different, they are not equal, and hence we get the output resulting saying that it's a normal ECG. And the same process is continuing along. The same process applied for different wavelets. For example, hyperkalemia and myocardial infarction. And following the program and running the program, as we run the program, we get a GUI window. As you can see, there are 4 push buttons. One is to compare normal ECG, one is compare dystocardia, other one is compare hyperkalemia, other is compare myocardial infarction. The algorithm of 4 buttons are one and the same. The only difference is we change the inputs. Once, for example, compare normal ECG. This is the output of the program. As you can see here, this is the input to the MATLAB system. And this is the wavelets of the respective database. And this is the ECGs of different abnormalities. When the wavelets are equal, we get a pop-up box showing that the wave is normal ECG wave. And if it's not a certain wave, then we get the resulting outputs. Now running the program. For example, this time we are going to check it with dextrocardia. Once we press complete dextrocardia, we again get the 4 buttons, 4 figures. The wave with dextrocardia with inverted P wave. Since the given resulted wave is a dextrocardia, we get the output as the wave with a dextrocardia with inverted P wave. And this is the resultant ECG waveform of dextrocardia with its respective wavelets. And again comparing with hyperkalemia. Again comparing myocardial insomnia. Thank you.